Hello everyone, my name is Adele and today I will be talking about the final project for controls. So for this project I have chose to work with an insulin pump. It's a technology that has been more widely adopted and it has helped people manage their diabetes much better compared to years before. So to start off, this is the insulin pump as we can see. This is the object that is to be tuned. It acts as the actuator of the system by delivering insulin through the cannula. And then this is the continuous glucose monitor, which is the sensor of the system. It basically takes blood glucose values from the patient's body and sends that data to the pod, and also to the companion mobile app that it comes out with. The system, the controller is this device. It basically is connected to both the pod and to both the insulin pump and the continuous glucose monitor or CGM. It basically is used to deliver the insulin levels in the body. It is basically used to control the settings of the insulin pump and determine different types of modes and different types of insulin delivery for different modes for different types of activities. Moving on to software hardware integration, the main concern with insulin pumps is, of course, to deliver adequate insulin and to deliver insulin properly, so that when the patient's blood glucose levels are high, the system can deliver insulin, and so the blood glucose levels can go down. But they don't want to go. It shouldn't be too low, otherwise we can risk having hypoglycemia, which can cause health hazards. A PID controller is developed for this type of system, typically speaking, and this variable in this case to be tuned will be the difference between the target glucose value of a patient and the final glucose value that are measured by the insulin pump itself and the CGM and so on. Moving on to the controller itself, these are the These are the constants of the PID controller, as we can see. There's more information in the references, but to talk briefly, we basically obtain the gain factor by minimizing the cost function, which basically takes into account the differences between lower bound of glucose and typical glucose levels and glucose levels when they're higher than 180 degrees. And if we minimize that function using some more advanced controls, we come to get that number. It is a similar thing with the derivative and integral time constants. And as we can see that it is the controller parameters, the Kp, Kc, and Td and Ti constants were obtained through internal model controlling. It refers to creating a model. It involves creating a model of a representation of the process within the system itself. This allows for any deviations between the desired and actual behavior to be detected and adjusted, thus allowing for better control of the process. In this case, the process delivering insulin to the patient and maintaining blood glucose levels. Heuristic tuning is a method that we have typically used in the class, but it doesn't apply for this. That can lead to instability in the system, that can lead to errors in the system, and it is also typically seen as suboptimal compared to other better control methods, other better control and tuning methods. System modeling. So this slide basically refers to what the planned function of the insulin pump itself will be. As we can see, it is a relationship between how much glucose level is in the blood and how much insulin is being delivered by the insulin pump itself. And the pump basically delivers insulin based on the difference between the target glucose and the actual blood glucose level using something called a correction factor. And I personally use continuous mathematics to develop the model, as CGM reads the glucose value levels from patient blood at a continuous interval. This is my Simulink model and the code. Pretty much standard, pretty much nothing too bad. It's just we have a target glucose level of 130, which is an arbitrary number that I really chose. The actual blood glucose is represented by a pulse function, and then these are the other things, like this is the Kp block, the K block, the integral block, the derivative block, the planned function, and the correction factor. Moving on, this is a system that results from between the Simulink models. So if we do not tune the system, versus tuning the system, which is represented by the blue line, and the non-tuned system is represented by the yellow line. If we don't tune the system, we can see that in the beginning there is a higher degree of oscillation in the amount of blood, in the difference between the blood glucose level, in the blood glucose values that the patient has in their body, or that the patient will have, and the and the values are also not as steady as compared to when the values are tuned, as we can see. So also when we tune the system maintains a lower blood glucose level compared to when the system is untuned, which means that higher look, and it is closer to the average of 105, 110 milligrams per deciliter for the human, which is a better thing than having just a 130 milligrams per deciliter in the human body, since that is on the higher side. As for system development and concerns, we definitely, there's a lot of simplifications involved in making this model. For example, I assume that a person will eat exactly at 8 hours, and every time they eat, the blood glucose level will like shoot exactly to 180 milligrams per deciliter. But that is definitely not the case. There's a variation between how the CGM reads values and how much sugar is in the blood and everything, how much sugar is in the food that was consumed and everything, and how the human body functions. So we definitely want to take that into account when the insulin is delivered, and be able to adjust those insulin deliveries to those variations. Another thing is that insulin stays in the body for a long time, and it doesn't just dissolve away. Um, it doesn't simply dissolve away. And so we also have to take into account how much insulin is in the patient's body before we inject, while the insulin is being injected. So there should be a control control mechanism for that, safety mechanism for that. And the other concerns are listed. Pump and CGM can lose connection, since that can happen with especially Bluetooth ones. So there should be a safety. There's typically a safety mechanism for those to make sure that the insulin isn't over or under delivered, and as well that because the insulin, like the insulin pump itself, has a reservoir of insulin, we should take into account how much insulin is left, and we should be able to we should have a system to notify the user how much insulin is left, and to notify them before the pump runs out of insulin. Overall, this technology has definitely made diabetes management a lot easier, and there have been sources where people have told that they have been better able to manage blood glucose levels, since the system has been more automated. It's the less manual work, and in sharing information with the health provider through the means of cloud data also ensures better treatment for diabetes patients and helps improving in their lives around the world. Overall, thank you very much, everybody, for coming and listening to this presentation. Bye.